This is Emily. Very impressive.
Okay, can you hear me?
Yep.
All right, so my name is Emily Batt. I'm a senior. I'm very excited to share my path on undergraduate research with you, and I think you'll probably see a lot of overlap with what Jose had to say. But I'm from Merrimack, New Hampshire, and I'm studying physics. I'll be graduating in the spring. Rewind a little bit to 2007. I had just graduated high school, and I was really excited, but I did not know what I was going to do at all. So I was a little panicked. But I knew I was coming to Northeastern, and I just wasn't quite sure what I was going to study yet. I was thinking a little bit of everything. So I guess the obvious choice for my major was to be undeclared. But that turned out to be really great for me because I got to try out a lot of different things. And my first experience in research was actually in the humanities. I studied a topic called the Stadia, which is the melancholy of 17th century monks. So not science at all, but very interesting. And I really like to get into the very heavy reading, do a lot of analysis on the text, and do a lot of writing. And I like the autonomy of the research. So it was a really interesting project. But it came time for me to choose a major. And I had been thinking about physics. I just wasn't too confident in the math. I was a little nervous about it, but I knew that physics could really explain a lot of different phenomena. It could tie together a lot of different disciplines. So I thought, there are a lot of opportunities. Why not? I'll give it a shot. But it came time to find my first research experience, and I was a little nervous because all I had done was study really sad monks. So I didn't quite know what to do. But I took the advice of one of my professors who recommended the research experience for undergraduate grants. Those are probably what Jose was alluding to, which are grants funded by the National Science Foundation that are usually 10-week summer programs that happen all over the country. And at a ton of different universities and a ton of different topics. You get guidance from faculty. It's kind of like a mentorship. There's tons of areas you can study. But the caveat is that they're in high demand because students from all over the world are trying to get into these, so you really do need to apply to a lot, especially if you've only studied monks. So I was one of those people who applied for 23 of them, and I was offered one, and it was perfect. It was the very last one I applied for, so I was lucky. So for the summer of 2009, I moved to Oregon State University and did research in physical oceanography. I worked with Professor Jim Lurzak. He's at OSU, and my project was to analyze the evolution of a certain type of subsurface wave. And it was really cool because I got to look at the data that had already been collected, and then I got to go on a 10-day research cruise and collect my own data, and then I got to present my results at a national conference. So in a nutshell, internal waves are subsurface gravity waves, just like you would see crashing on the beach, but below the surface. And they're important to study because they carry a lot of material, and we need to understand how those waves might transport waste or sediment or biota. So I was using data collected from hull-mounted instruments and turning that binary data into images of waves. So this is a wave that was moving towards shore for about 12 hours. So that's one picture of a wave. And it was a lot of fun to work as a member of a scientific team. The cruise was so interesting. We dumped fluorescent dye in the ocean, so that's Gatorade colored stuff is actually fluorescent dye. And we watched how the waves carried the dye. Beneath that, I'm putting diaper cream on one of our instruments so that seaweed wouldn't grow on it. This zinc stops the seaweed. And those are some of the images that I had by the time I had looked at all the data. So after that program, it was time to go back to school. And as a part-time job on top of classes, I decided to try to do some more research. and I joined a program called the Advanced Program at Northeastern. It's another NSF program occurring at universities all over the country, and it's aimed at increasing the number of female faculty in STEM fields, just kind of making it a more welcoming place for female faculty. It was a cool place to work because you had engineers and scientists doing research side by side with sociologists, so it was interesting to see the social side of scientific discipline. And following that program, it was time to find my next co-op. So I applied for another summer program, something called the Steamboat Summer Scholars Program. Every single year there's one Northeastern student who works at Dana-Farber and is funded by the Steamboat Foundation. And you actually work with, or you live with 13 other students who are working totally different internships. Some are in New York, some are in Boston, but you get together about every weekend. And there's also a very generous grant of $12,000 for the 10-week program. So still time to apply. Middlers and juniors can apply, so if you're a freshman or sophomore, definitely keep it in mind. You can be any major at all and apply for the Dana-Farber job. And in addition to doing research, you can also participate in some leadership development experiences through the Steamboat Foundation. So this is me with James Watson, one half of Washington Kirk. It's pretty cool to meet him. And at Dana-Farber, I was in a computational biology lab, a cancer systems biology lab, and I was looking at how protein interactions, actually using the same yeast-2 hybrid method, how those networks can explain the development of disease, and looking at the web of interactions of proteins in the whole body, and trying to see, well, what happens when one protein gets mutated? Does it knock out all of its interactions, or are some interactions preserved? And it was an interesting lab to work in because you're looking at these tiny molecules from a very systemic approach, very global approach, and there's a lot of computational biologists and computer scientists working right next to biologists on the lab bench. So I had two projects there, looking at mutations in proteins and trying to find alleles to test on the lab bench. These were the 3 mentors I worked with there. And I liked that job because it exposed me into the area of network science, the idea that you can look at a number of different systems with the same kind of computational approach. And while I was at a conference relating to network science, I met Cesar Hidalgo. He was actually just starting a new group at the MIT Media Lab, and I needed something to do for that fall following the Steamboat summer. So I kind of just reached out to him and said, hey, I have some experience in systems biology and networks. I really like what you're doing. Do you have any need for an undergraduate research assistant? And luckily he did. So for the fall of 2010, I was looking at economic development from a networks-based approach, trying to see how 2 products in the global economy could be related, and whether using a networks representation can explain why countries develop so fast, or why some get stuck and really can't develop. And it was a lot of coding, a lot of writing MATLAB to make simulations. And I'm on my final co-op now, so maybe you're wondering, can research experience translate to industry jobs? And I would say definitely. I'm working at a product development company right now called Fikst. It's in Woburn, Mass. And it's basically an engineering consulting company that does all sorts of things to help get products to market faster for client companies. So every day I'm brainstorming, or maybe I'm sketching new ideas, doing a lot of CAD and 3D modeling, which I had never done before, doing a lot of prototyping. We have a 3D printer in-house. Sometimes you're building simulations to test ideas for products, and studying material properties. So this is just a sampling of some of the products that my company has made. We have a body buffer, a kitty litter box, a loop that controls PowerPoint presentations, and a tool that puts your golf ball on the tee. So these are just some of the consumer products that we do, but we actually mostly do biomedical products. So here's a sample of an instrument development process. A company comes to you and says, well, we need a product that does X, Y, and Z. So we have an idea, we build a very rough prototype, go to Lowe's, get some 2x4s. The next step after that would be to 3D print the idea, and after that you move to injection molding. So by the time you finish, you have a very nice, white, shiny product. And what you just saw was actually part of a system called the Pippin Prep system. It's sold by Sage Science, and it's connected to what I've been doing mostly there. which is a system that makes gel electrophoresis automated. So the parts that you just have to do by hand, like using an X-Acto knife to cut out pieces of agarose gel, is now all completely automated. So it takes out hours of labor and just turns it into minutes of labor. So working there, I think, has shown me that research experience is really transferable. All the skills that you get in a lab could move directly to a company, especially if you're working in R&D. But some tips, I think, would be honest and eager, especially as an undergraduate. You're not expected to know everything, which is the best part about doing research as an undergrad. You can say, I don't care what's going on, and you have people there to help you, and that's how you learn, and that's how you get better. So as long as you're eager and excited about what you're doing, that's all you need. Keep notes. You're going to forget how you did things, but if you have a notebook, then you'll remember. Definitely maintain your writing skills. No matter what you're doing, you're going to need to write about it. So keep that up. Cast a wide net. I would say it's important to try out a lot of different things. Don't worry about being pigeonholed in one area. It's never too late to say, well, I did this, but now I want to move on to something new. Talk to the grad students. They're an awesome resource, especially if you think you might want to go into that field. Talking to the grad students can help you figure out if you do. And be resourceful and network. Sometimes that seems a little scary or abstract, but it can literally mean just sending an email and saying, I'm interested in what you do, can we talk about it? And definitely ask early for your recommendations. You want to give everyone ample time to write them. And that's it. Any questions? Awesome. Thanks.
Well, are you still fearful about mathematics?
I've gotten a lot better, and I've now embraced the difficulty. It's very difficult, but it's very rewarding, and I'm not fearful anymore, that's for sure. Yeah.
So you mentioned that product that you showed is sold by another company.
Yep.
So Fikst, they develop the product and then they sell the patent?
It's actually, we're approached by companies. We're essentially an engineering consulting firm, so companies will come to us. And sometimes they have a concrete idea of what they want or need, or they've maybe already started on something, but other times it's just, sometimes they say, well, we have a product that works really well, but this one little component is broken. So we get the full range. You know, sometimes we're starting from scratch, and sometimes we're not. Yeah.
Could you say some more about Project Advance? Is it open for all people in math, science, and engineering?
So the work that they do is tailored towards increasing the number of female faculty in those fields, but they always have students there working. I know they have a number of work study students, and they might have positions open that aren't work study, but I was helping them conduct focus groups on the importance of international collaboration, so kind of just there to help facilitate those, and also work on a project looking at publication patterns. So that was 2009, and it's a 5-year grant, so it's definitely still ongoing. They're doing a lot, but I'm not sure where those projects stand now. Yep.
What do you plan to do after you graduate?
Good question. It's the golden question. I've put out a couple applications for graduate school, but I definitely want to work in product development. I really like that it's project-based. As you can see, I've kind of jumped around a lot, so it's nice to be able to really dive into something, learn it, forwards and backwards, and then be able to move on and do something totally new. I like that process of learning from scratch, I guess. So I think product development is a good way to get that throughout a whole career. So looking into programs for that, and maybe working a little bit before.
What was the most challenging part of getting into research or doing research?
The most challenging part, and I still find it challenging, is managing the pace of the work, I guess. Oftentimes in research you're working very independently. You might not be checking in with a professor very often, so you really need to set marks for yourself to hit, or I know for me it's sometimes just making a to-do list and making sure I'm moving at a reasonable pace, because it's easy to get sidetracked or to, I don't know, to spend too much time on one thing. So I think when you're working by yourself, that's definitely a skill you develop. something I'm still working on. The hardest part of getting into research, I think, is getting your first research experience. Because once you say that you've done scientific research, it's a lot less of a gamble on you, I guess. Professors know that you have certain skills needed to do research successfully, but you have to get your foot in the door first, which is why I say, take the time to apply to 25 of those programs, because if one pans out, then that's all you need. But it's definitely a huge time investment in the beginning. A lot of essays. Great, thanks.
Thanks.